Hello and welcome back to another calculation in chemistry. This question said a current of 8.0 amps is passed through an aqueous solution of silver nitrate for 2 hours 30 minutes. Calculate the mass of silver deposited. The atomic mass of silver is 108. Then 1 Faraday is 96,500 coulombs. And then it's a question in 2004. As usual, we're going to start with solution and then we write the ionic equation. So silver is plus 1. So it's going to be having 1 electrons and then it will gain that to form what? Silver atom. 1 silver atom. So this is representing 1 Faraday and this is representing 108 grams. Right? Okay, so the question is saying that we should find the current. A current of 8 amperes passed through an aqueous solution of silver nitrate for 2 hours 30 minutes. We should calculate the mass. So since we are calculating the mass of silver, then first and foremost, let's first relate something. Now we know that 96,500 coulombs of electricity will produce 108 grams. Then the other column that we will get from this time and this ampere, let's calculate it first, because charge is equals to what? Current times what? Time, right? So we are giving our current to be 8 amps and then we are giving our time to be 2 hours 30 minutes, right? Now we don't use hours and minutes in calculation. We have to convert these 2 hours 30 minutes to what? Seconds. So in doing that, we'll either do it this way or any other way we desire. Now we can tie up this time to be 2 hours 30 minutes means 2.5 hours, right? So it's not up to 3 hours, 2.5 hours. So how do we convert hours to seconds? We just multiply it by 60 to minute and then 60 again to seconds. So this is equivalent to 2.5 times 60 times 60. So this will give us our answer in what? Seconds. Right? Okay, so let's go about the multiplication. Now, in doing this, we know that this expression means 5 over 2, right? Times 60 times 60. So 2 here is 1, and then 2 here will give you what? 30. So we'll be having 5 times 30 times 60. So we have 5 times 30 times 60 seconds. Now this 5 times 30 and times 60 can be made simplified in this way, right? For easy multiplication. So this is going to give us, let's start with this value first. 3 times 600 will give you 1800 times 5. It's going to give you 0, 0. This time is 40, right? Write down 4. Write down 0. Carry 4. This times this will give you 9. So it gives you 900 seconds, right? Okay. So that's our time. So now we can now look for the charge. Charge is going to be the current times the time. Okay, so 8 times 9 is going to give you 72,000 coulombs. So this is the charge based on the question that has been given to us, right? Okay, so if that's gotten, then let's do our relationship. Remember our relationship. 1 Faraday of electron produce 108 grams of silver, right? Then what will this coulomb, and you know that 1 Faraday is 96,500 coulombs, right? So we have 108 grams. Then what will 72,000 produce? So we have 72,000 columns will produce what? X. Remember our simple method, so we do cross multiply. So this times this will give you 96500x, and is equals to 108 grams times 72000. So x will be equals to, we divide both sides by 96,500, 108 grams times 72000 divided by 96,500. All right, so we're going to be having this, and then this will take off this, and then x is equals to 108 grams times, let's do this value divided by this value to see what we're going to get. So it's going to give us 0.7461. So let's multiply this value now by 108, right? Times 108. So we're going to be having 80.58 grams. So what this answer means is that when a current of 8 amperes passes through an aqueous solution of silver nitrate for 2 hours 30 minutes, the mass of silver that will be deposited will be what? 80.58 grams. So this brings us to the end of this calculation. I'm going to be seeing you in the next one. Bye for now.